wabarakatuh, and a very good day to everyone. I would like to begin by extending warmest regard to Associate Professor Dr. Atiqah binti Muhammad Arif, my respected lecturer, and to all my fellow classmates. Thank you for your taking the time to watch this presentation. My name is Shukri bin Juso, P156824, and today I am very excited to present my second assignment for this subject, titled The Impact of Extracurricular Activities on Academic Performance, Evidence from Student Data. Academic is often linked to the factors like study habits and support systems, but the role of extracurricular involvement remain less clear. This study utilized the student performance data obtained from a Kaggle comprising about 2,392 student records and 15 key variables. The dataset includes the wide range of academic and demographic information such as GPA, gender, age, weekly study time, parental education, tutoring support, and participation in extracurricular activities. By analyzing this data, the study seeks to uncover meaningful patterns and associations related to student academic performance, offering insights into how various behavioral and support related factors may influence GPA outcomes. For the objective, I got 4 objectives over here. The aim for this study is number 1, to explore student characteristics based on academic and personnel variables. Number 2 is to determine whether extracurricular involvement influences student performance. Number 3, to assess the relationship between the study time and GPA using linear regression analysis. And the last one, to apply statistical methods, t-test and linear regression using R programming for data interpretations. For the method, the study employs R programming for statistical analysis and visualization. 2 main techniques were applied, which is number 1 is EDA or exploratory data analysis, and number 2 is statistical tests. For number 1, analyze GPA distribution, study time pattern, and gender differences, visualize relationship using histogram, box plot, bar chart, and scatter plot. For the statistical tests, I use the hypothesis testing, independent 2 sample tests, t-test in R, which is the null hypothesis. There is no difference in GPA between students with or without extracurriculars. Alternative hypothesis, which is there is a difference in GPA students with or without curriculars. And for the simple linear regression, the model relate about GPA and study time weekly. And the purpose is to examine the predictive strength of study time on GPA. We can see over here on the EDA, on the first graph is histogram. The GPA values are spread widely even between 0, 2, and 4, with a noticeable peak around 2.0 to 2.5 range, indicating many students fall into the mid-performance category. The distribution is slightly left skewed, meaning few students have a very low GPAs compared to the high GPAs. For the second is a box plot, compares between GPA between students who do not participate in extracurricular activities, which is noted as 0 on the left side, and those who do, number noted as 1 on the right side. Students involved in extracurriculars tend to have a slightly higher median GPA and a narrower interquartile range, suggesting a modest positive impact on the academic performance. And then for the bar chart on the left shows that the number of students is almost equally distributed between the two gender groups, which is male and the female. The box plot on the right side indicates that both gender have a similar GPA distributions with a nearly identical medians and range, suggesting no significant difference in academic performance based on gender. Alright, then we go to the t-test. When I run the R programming, the value of the number of p-value is 4.32 times 10 minus 6, which is less than 0.05. And then for linear regression, the first one, on the left side is a scatter plot, shows the slight positive trend between study hours per week and GPA, as indicated by red regression over here. However, the data points are widely scattered, suggesting that study time alone is a weak predictor of GPA, with many other factors likely influencing academic performance. And for this box plot shows that weekly time study is nearly identical across the gender, with both groups having similar medians and distribution ranges. Alright, for the linear regression around the R programming, which is the number of p-value is 2.2 times 10 minus 6, which is minus 16, which is less than 0.01. Alright, now I go to the explanation for the test. So basically, since the p-value for the t-test, since the p-value is less than 0.05, we reject the null hypothesis. This means there is statistically significant difference in GPAs between students who participate in extracurricular activities and those who do not. So we reject H null, meaning that students who participate in extracurricular activities have significantly difference in GPA, which is higher. And then explanation for the linear regression. The simple linear regression model, which predicts GPA based on weekly study time, reveals a weak but statistically significant relationship. Okay, we can see the R square value is 0.03214, which indicates that only about 3.2% of the variance in GPA is explained by the time study alone, suggesting limited practical influence. Alright, and then the adjusted R square is slightly lower, which is 0.03173, which is expected given that the model includes only one predictor. Despite this, the F statistic 79.36 on 1 and 2390 degrees of freedom, and the very low p-value confirm that the model is statistically significant. In terms of coefficient, the intercept is 1.6226, meaning that students who report 0 study hours are predicted to have a baseline GPA around 1.62. And the coefficient for study time weekly is plus 0.029, which implies that each additional hour of study per week is associated with an increase of approximately about 0.021 in GPA. While this effect is statistically significant, it remains small in magnitude, which is the p-value is less than 0.01. And then the model of residual standard error is 0.9005, indicating that predicted GPA deviate from the actual values by roughly 0.9 points on average. The residual range from -2 to +2.31, reflecting variability on prediction accuracy and reinforcing the idea that GPA is influenced by multiple factors beyond just study time. For the conclusion, this analysis demonstrates that participation in extracurricular activities has statistically significant and positive relationship with the student academic performance. Students engaged in activities such as sports or music tend to achieve higher GPA outcomes compared to their peers who are not involved. While weekly study time also shows a positive correlation with GPA, its impact is relatively modest and explains only a small portion of the variation in academic results. These findings suggest that although study habits are important, broader and support systems such as tutoring, parental involvement, and personal motivation may play a more influential role in driving student success. The use of statistical tools in R programming enable clear interpretation of this relationship, offering valuable insights for educators and policymakers aiming to design more holistic and evidence-based academic support strategies. That's bring my end of presentation. Thank you once again to Associate Professor Dr. Nur Atiqah binti Muhammad Arif, and thank you for your guidance. I hope that this presentation is informative and thoughtful. With that, I end of this presentation. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.